Alright, let's look at this problem called transform to sum tree. Given a binary tree of size n, where each node can have positive or negative values, convert this tree to a tree where value of each node will be the sum of the values of all the nodes in the left and right subtrees of the original tree. The values of leaf nodes are changed to 0. You have to modify the tree in place. Let's look at an example. This is an example. This is our original tree, and this is the output. It also gives an explanation. So the this node changes to 8 minus 4, this node changes to 7 plus 5, and what it returns. So basically, this node will be sum of its leaf nodes, which will be 8 plus minus 4 plus minus 2, which is what? So this node changes to sum of its nodes, which is 4. This is interesting. And okay, so basically, okay, let's come to a whiteboard. So what's happening? So this is our tree. So original tree is 10 minus 2, 6, 8, minus 4, 7, 0. Sorry, not 0, 5. So what's really happening is a node dot val essentially is sum of all nodes in left and right subtree. That is what we have to replace it with. So that means that for the leaf nodes, because they do not have any left child and right child, they will all become 0. However, for this node, it will change to sum of its nodes, which is 8 and 8 plus minus 4, right? And what will, so basically, this path returned 8, this path returned minus 4. What will this path return? And that's the important question. So this path will return whatever sum we got. So there are two things. One is like a node dot val. Let's say we define some function, right? So this function will do a node dot left, and we'll also get the value from node dot right. This is what node dot val will return. This is what node dot val will be, and what will be the return value? Well, return value would be original node dot val plus this, right? Right, we get it. So essentially, like minus 2 will change to 8 minus 4, which is 4. But what it will pass on to its guy will be this entire thing, right? Which will be 8 minus 4 minus 2, right? Similarly, 6 will change to 7 plus 5. But what will it return to this? It will return 7 plus 5 plus itself also, right? So that's what we have to sort of take care of. So let's implement this logic in code now. So we go to code. So what we're saying is we have to do in place. So let's do if root is null, well then return 0. Now if I'm a leaf node, then I will get 0 from both my left child and right child. But it could also be that okay, let's check if it's a root node. So if root dot left equals to null and root dot right equals to null, right? If it does not have a Oh, this is a void, so you can't return a. It's a void. So we do. Let's call this. We call another function to some tree util and just pass root to it. And what I will do here is, let's add also one case. If root is null, then we just terminate. And we'll use this to some tree util because it gives us a return value also. And we'll ensure that it will never be null. So that's fine. So if it was initially, now if it's a leaf node, so if root dot left is null and root dot right is null, that means it's a leaf node, then let's do this. Int temp equals to root dot val. Also do this. If root equals to null, then return 0. Call it node val, right? And now what I'm gonna do is, okay, let's see this. So this, let me ignore this. So I save my original value. Then I do call it on left and right subtree, right? So to some tree util root dot left plus to some tree util root dot right. So I'll get the sum of my left child, sum of my right child, and myself is what I will return. So what I will return is this new root dot val, which is the sum of my left subtree and right subtree, and what my original value was. This is what my parent will use. So that's my general idea. Let's compile and run. Okay, gets a compilation error. Let's try and fix that. It says root.data. The data structure, that the way that they have defined. Lead code uses val, so that's the confusion. Let's try and fix some of that stuff. Cannot find symbol. Why can I not find symbol? Cannot find symbol. Two. Okay, let's just ensure that yeah, it's all there. Line number which 139. Variable root of type node cannot be found. Oh, again this same problem actually. Everywhere this has to be changed. Okay, the first test case passes. Let's submit and see if it works for everything or not. And it does work. All right.